Selby here. I'm going to do a nice little lesson on 2.8, which is proving angle relationships. So we've talked a little bit about angle relationships in the past. Now we're going to get a little bit more in depth for it. Let me actually start the PowerPoint so you guys can kind of see it. Kind of point of this lesson is to be able to use proofs, which we've been building with proofs. We started out with algebra, right, for proofs, which is stuff you should be pretty familiar with from last year. Then we moved on to segment and adding segments. And you know that a lot of that we know is like common sense, right? Like if you add this section and this section together, it equals the whole section. Like we know that from segment addition postulate and everything. Now we're going to start proving angle relationships. And this is where it gets a little bit more complex. And you're probably like, oh, Mr. Selby, proofs were already so complex to begin with. Like I said, this is important because we're proving things. We're essentially outlining how to do an argument, okay, how to prove something using evidence. So that's got important real world significance to it in and of itself. But at the same time, we actually use angles a lot more than you may think. You use angles a lot when you're building. You use angles a lot even when you're decorating. All right. But a lot of times you use angles when you're driving and giving directions and stuff. All right. So you might say we know adjacent angles are angles next to each other, but that just gives you the definition of adjacent, which means next to each other. So you might say go inside the adjacent building. That means the building next door. You know. So if somebody tells you that, it's important to know what it means. So this kind of will help out a little bit, and I'm hoping that you'll be able to use this in the real world. I know I do from time to time, so hopefully you do too. All right, so we identified and used special pairs of angles. We've gone over angles that are supplementary, which is a pair of angles that add up to equal 180. We've gone over angles that are complementary, which is a pair of angles that add up to equal 90 degrees. We've gone over vertical angles, which are angles that are across from each other that are equal. We've gone over adjacent angles, which are angles that are next to each other. Okay, so we've gone over quite a few pairs of angles, but today we're gonna do a little bit more with it. Now we're gonna write proofs about these special angles. All right. So protractor postulate. This may look familiar. It may seem like it's the same postulate you just used for the ruler postulate. They're pretty similar. This one, just instead of being the ruler postulate, which was 2.08, this one's the protractor postulate. So given any angle, the measure can be put into one-to-one correspondence with real numbers between 0 and 180. If ray BA is placed along the protractor at 0 degrees, then the measure of angle ABC corresponds to a positive real number. All right. So as you can see here, we've got BA placed along the protractor at 0 degrees. All right. Then the measure of ABC, which is this larger angle right here, corresponds to a positive real number. And we know this. They said the same thing as the ruler postulate. As long as it starts at 0, whatever number it goes to is the total size of it. All right. So let's keep going with it. Angle addition postulate. Okay, so this one's pretty important. So this is where the ears need to perk up. You guys got to listen to this for a little bit, okay? All right, so essentially when you have this angle right here, this blue one, which is Y, okay? This blue angle, CBD, okay? And then you have this angle right here in red, which is ABD, okay? So this angle and this angle, if you add their degrees together, it equals the total angle, which is the green, okay, which is CBA. All right, that's important. That's called the angle addition postulate. If you have one section of an angle plus another section of an angle, it equals the total angle. All right. So construction, using a protractor, a construction worker measures that the angle a beam makes with a ceiling is 42 degrees. What is the measure of the angle the beam makes with the wall? All right. So the ceiling and the wall make a 90-degree angle. Okay, let angle 1 be the angle between the beam and the ceiling, and let angle 2 be the angle between the beam and the wall. So essentially, as you know, when a wall hits a ceiling, it makes a 90-degree angle. The beam is making a 42-degree angle. Okay, that's angle 1. And angle 2 is the beam between the wall. So as you could probably guess, 42 plus whatever the beam is with the wall, when you add them together, they're going to equal 90. As I said, angle 1 plus angle 2 is going to equal 90. So we know angle 1 equals 42 degrees. So we do We subtract 42 from both sides, and we're left with angle 2 and whatever 90 minus 42 is, which should be like 48. Yep, and that's going to tell us what the measure of the angle, that's the measure of the angle the beam makes with the wall. Okay. All right, your turn here. No word problem needed. Why don't you guys, I'm going to stop talking for about 5 to 10 seconds. It would be great if during that time you're able to pause it and try and work on this on your own. All right, hopefully you were able to solve this one on your own. All right, if you didn't, please pause it now or watch because I'm about to go over the answer with you. Okay, so this one's going to be 104. All right, and we're trying to find here the measure of angle 1. Okay, so let me quickly go over how to do this. Let's see. Oops. Let's go tile window to the left. And let's go with this. All right, so angle 1 plus angle 2, when you add them together, they're going to equal the whole angle, which is JKL here, right? We know that. Let me see if I can zoom this in a little bit. Oh, maybe not that much. Okay. We know that angle 1 and angle 2 we know angle 2 is 58 degrees. We don't know angle 1. We need to find the measure of angle 1. So that's why there's a question mark in there. We know JKL is 162. And we know, again, if we add 1 and 2 together, we get JKL. So I write that equation. Angle 1 plus angle 2 equals angle JKL. And then I sub in what I have. I know angle 2 is 58, so I put a 58 in there. I know JKL is 162, so I put a 162 in there. Angle 1 plus 58 equals 162. I subtract 58 from both sides. 58 minus 58, it comes out to 0, so angle 1 is left by itself. 162 minus 58 is going to be 104. And, yeah, that's what happened there on that one. All right, let's keep going. Okay, the supplement theorem. If two angles form a linear pair, then they are supplementary angles. Angle 1 plus angle 2 equals 180 degrees. Yeah, we know a straight line, right? A straight line has a degrees of 180 degrees, right? That's a measure of this. So if you add both these together, because they're supplementary, they're going to equal 180 degrees. But they're a linear pair, so they're already, the straight line's 180, so you know they're going to be supplementary. All right, complement theorem. If you see a right angle here and you see two angles, if you add both those angles together, you're going to get 90 degrees. It's the complement theorem. The non-common sides of two adjacent angles form a right angle. The angles are complementary sides. So these are the non-common sides, this one and this one. This is a common side. They both share it. You add if these non-common sides make up their own angle, and that angle equals 90 degrees, these are complement angles. All right. At 4 o'clock, the angle between the hour and the minute hands of a clock is 120 degrees. When the second hand bisects the angle between the hour and minute hands, what are the measures of the angles between the minute and second hands and between the second and hour hands? So, lower view here, bisects means cut in half, okay? Remember, halves are even, not just cut into two pieces, cut in halves, okay? So, like I said, halves are even. So both of those angles are going to be equal. So make a nice little pretty sketch here of the situation. Times 4 o'clock. I don't know how many students can read these nowadays, but they're a classic. Time is 4 o'clock, and the second hand bisects the angle between the hour and minute hands. So as you can see, it cuts it right in half right there. So essentially what you can do here is you know the total angle is 120 degrees, right? And you know this cuts in half. So in order to figure out what both these angles are, you cut 120 in half. So half of 120 is 60, so that's going to be 60, and that's going to be 60 because they're the same thing, because they're both halves. But let's let the PowerPoint go through it. Use the angle addition postulate and the definition of an angle bisector. Since the angles are congruent by the definition of an angle bisector, each angle is 60 degrees. Both angles are 60 degrees, it's like Mr. Selby said. Use the angle addition postulate to check your answer. Measure of angle 1 plus measure of angle 2 equals 120. 60 plus 60 equals 120. Your turn. Quilting. The diagram shows one square of a particular quilt pattern. If the measure of BAC equals the measure of DAE and the measure of BAE is a right angle, find the measure of CAD. All right. Let you guys take a quick second, see if you can solve this one on your own. I'm going to stop speaking for about 5 to 10 seconds. If you could pause it and try and solve it. All right. Hopefully you're able to solve this one on your own. The diagram shows one square for a particular quilt pattern. If measure of BAC equals measure of DAE equals 20, and measure of BAE is a right angle, find the measure of CAD. Hopefully you're managed to solve this for 50. Okay. And I am going to really quickly oops. Sorry about that, kids. Oops, again. This isn't going so well, but I felt like it went better the first time. Come on, let me slide to the right again. That was so helpful. There we go. Or to the left. That works too. Where did my... All right, I don't need it. Actually, I did kind of need it. We'll minimize. There we go. All right. So we know BAC, right here, BAC, plus CAD, right here, plus DAE. You add all three of these together, we know it's going to equal BAE, the total angle, because the angle addition postulate. We know BAE, we're told here in the problem, BAE is 90 degrees. The whole big angle is 90. We know DAE is 20 because it says in the problem, DAE equals 20. We also know that DAE is the same measure as BAC. And if DAE equals 20, then BAC better equal 20. CAD, we don't know, question mark. All right, so BAC plus CAD plus DAE equals BAE. So these three small angles add them together, they equal the big angle. We know that. Let's sub in what we know about each one. BAC we know is 20. CAD we don't know, I just leave it in there as CAD. DAE we know is 20. And BAE we know is 90. So we got 20 plus CAD plus 20 equals 90. Let's combine our like terms. We're going to get 40 plus CAD equals 90. Subtract 40 from both sides here. Okay, we're going to be left with CAD. 90 minus 40 is going to be left with 50. Okay, and therefore 50 is our correct answer. All right, and I think that's good for today. So what I'm going to do here, guys, is I'm going to stop today's video. If you guys have any questions or concerns, you know what to do. You can always reach out to me on Schoology. You can always email me. You can always come to my office hours. Please reach out if you're having any issues or anything, and I'd love to be able to help. If it helps too, don't forget it's great to rewatch these videos. Okay, it's great to watch some of the videos from the past, review a little bit. Okay, check out some of the quizzes and tests. A lot of them are still open for you to do retakes. Okay. And I'm accepting still assignments from the beginning of the year. So if you could just try and get those in, I think it's important. Let me know if you need any help again. I hope everybody is staying happy, healthy, hydrated, safe during these times. And I hope everybody's doing well. Can't wait to see you guys soon.